1h here. All right, so this one is probably the longest of all the problems so far on the study guide. Just to give a broad overview, e to the 3x times cosine of 2x. We've done enough of these in class where if you see an e to the paired with a cosine or sine, you should know that we're going to try to do escape method, but we got to do two diagonal arrows first. I'll talk about that as I go through it in details. The other thing that makes this one harder or more complicated is that I got a 3 here and a 2 here. And that's going to give me all kinds of crazy fractions. But I will try to give you some tips for how to deal with things more easily. So, let's go. I got tabular method with escape method. So I got a dir side and an int side. Now, with this one, e to the 3x and cosine, you can actually choose to put either one on either side. I typically would rather take derivatives of my trig functions because it's easier to keep track of positives and negatives and integrate the e to this. That's what I'm going to do here. So I'm going to write cosine of 2x, and then I'm going to write negative sine of 2x. And then I get negative cosine of 2x. Oh man, I'm forgetting my chain. This one has a 2 out front. Negative 2 sine. And this one, after multiplying again, we get a negative 4. All right, on my inside, I got my e to the 3x. And then I get 1/3 e to the 3x. And then my next one is going to be 1 over 9 e to the 3x. Now, I'm going to do two diagonal arrows. I alternate signs plus minus. And then is going to be my escape method. Now, whenever I do my escape method, I do a back integral. This one is plus because it's the third arrow. I always alternate plus, minus, plus. So what I'm going to do is rewrite this whole thing out. This product is what this integral is equal to. So I'm going to leave myself some space here. I'm going to write the integral of e to the 3x cosine of 2x equals. So I just copied this right here. Now, diagonal, diagonal. Those guys get multiplied. So what do I get? I get 1/3 e to the 3x times cosine of 2x. Now, I put this one first just because in my brain I like having the e to the out front. And then look, when I do this product, I get a double negative. And I get plus 2 over 9 e to the 3x times sine of 2x. And then I get minus. Do I get a minus? Yep. So here, notice, I get a minus from this, and then an integral. And then I get the product of what's left over there. So I wind up getting 4 over 9 times e to the 3x times cosine of 2x dx. All right, so it's messy. There's lots of things that make this messy, but the thing that I want to focus on the most to simplify things is the fractions. Notice I've got a 1/3 and a 9th and a 9th here. So what I'm going to do is rewrite this whole line multiplying everything by 9. I choose that because multiplying by 9 will simplify all of these pieces here. And it'll eliminate fractions and just make our lives easier. So I get 9 integral e to the 3x cosine of 2x, the dx, equals. All right, when I multiply this one by 9, I'm left with a 3 out front. E to the 3x times cosine of 2x. Plus, when I multiply this one by 9, I get a 2. 2e to the 3x times sine of 2x. And then when I multiply this one, I'm going to write minus 4 integral because I get that 4, and then it's easy. You'll see in a moment why I want that 4 out front. So that multiplied by 9 just leaves me with the 4. Then I get e to the 3x times cosine of 2x with the dx. Now, we've been over this one in class, so I'm not going to go into too much like, wait, what the heck just happened? But what I want you to see is that this integral right here is the same as this integral right here. And I can do algebra on this equation. What I can do is add this 4 times that integral dx to both sides. And if I add 4 times that integral dx to this side, notice that like e to the 3x cosine of 2x, e to the 3x cosine of 2x, they're the same thing. So what do I get when I add 4 of that integral plus 9 of that integral? Well, I get 13 of them. So I get 13 integral e to the 3x cosine of 2x equals exactly this right here. So I'm going to go like this, and I'm going to copy, and I'm going to paste, because I can. So I get exactly that right there. And then my last step is I just want to solve for this integral. So I just divide by 13. So I get the integral of e to the 3x cosine of 2x equals fraction bar. And the top, let's see if I can paste again. Paste. Yeah, look at that. I get the exact same thing again over 13. And that is my answer with a plus C. Now, comment, like, this is kind of wild. This is very different from the integration that you've done up until this point in calculus, because previously we've always like actually integrated. We've never done like some build out some weird equation and solve, right? But this is a really good way to do this. And as you move along, you know, sometimes we wind up doing integrals like this where we kind of, I would almost say we hack our way into finding the solution. So hopefully you're good with this. See you soon. I decided to come back to the video. Hello again. I'm here. I'm back. You may say, when do I know when to do 2 arrows, 2 diagonals, and an escape, or 1 diagonal and an escape? I've said this in class, but I just wanted to add it here. We do the double diagonal anytime we have an e to the and a sine or a cosine. Most other, and I say that like carefully, most other escape method problems where I have to get out, we can usually get out in the first line, right? Like I did with the ln problem that we had earlier. So that's all. I'll see you soon. Bye.